All right, so if you remember from the video about graphing Lorentz curves, our Lorentz curve, we have a line of equality, then we have our Lorentz curve, and then we can think of this area of between the Lorentz curve and the line of equality shows how big is the inequality. And so we're going to come up with a coefficient, and this coefficient is, well, we compare the area of A, of how big is, how far is it from being equal, compared to how far it could be. So how far it could be is compared to the area of this entire red triangle, right? So we're comparing how big is the inequality compared to how big it could be. And so that is A plus B. A plus B is this entire triangle. So that is our Gini coefficient. Now, as you can imagine, because our Lorentz curve is a curve, it's kind of difficult to calculate this. And also, our decile data is a little too rough. So for our decile data, it doesn't look exactly like a curve. It's a little bumpier, but it's difficult to calculate this. And so there is a formula for calculating it. The book talks about how to derive it. We are not going to do that. So we are not going to calculate the Gini coefficient because it's not useful for our purposes, but we still need to understand it. So the Gini coefficient shows how big is inequality relative to the maximum inequality that could be, which means the one person has everything. And then we know that the closer to 0, the more equal, and the closer to 1, the more unequal. Okay, and now we're going to go ahead and just look at the data. So we're not actually going to do the calculation for Gini. For Lorentz curves, we will do the drawings, but for the Gini, we will not do the calculations. Okay, so before we move on, I just want to show you some of the properties that the Gini coefficient satisfies. I'm not going to prove these, nor am I going to really expect that you necessarily memorize them one by one, but they're still important to understand. Okay, so first thing, we need symmetry. So to be a good inequality measure, we need symmetry. It shouldn't depend on who has the area income, right? So if we exchange so let's suppose right now you're in the top 20% and somebody else is in the bottom 20%, and we just exchange you two. We give your income to them and their income to you. That shouldn't change our inequality measure, right? So we shouldn't care about who is rich and who is poor. We should so everyone should be anonymous, and that's also known as symmetry, by the way your book talks about it. It should be scale independent. It shouldn't depend on the size of our economy. If we were to change our currency, so we doubled everyone's income in nominal terms, it shouldn't affect inequality, right? It should be only about how is the income dispersed and not about how much income there is total. It also should be independent of population. So it shouldn't matter how many people we have in our country, because we want to make it comparable across countries. And there's also something called the Dalton transfer principle, and this is probably the most important one. The other ones are just sort of basic ideas. And this is our measure should get worse if we take money from a poorer person and give it to a richer person, right? So if we take money from a person who is poorer and give it to a richer person, then our measure should get worse. And vice versa should also be true. If we take money from a richer person, give it to a poorer person, our inequality measure should get better. Again, I'm not saying we should take money from one group and give to the other. What I'm saying is our measure should pick that up if it happens. Okay? And the final is decomposability. We should be able to separate into different income sources. We're not going to deal with that one, although that's useful. So the Gini coefficient just happens to satisfy all 5 of these properties, and that makes it a pretty desirable measure, and that's why you see it used the most often. Incidentally, it's not the only measure in the world that satisfies these properties. So you might see other measures, but it's definitely the most currently the most common one to see. So let's go ahead and look at some data now. So I just got a sample of countries. These were picked somewhat randomly and also partially because they are countries that you might be familiar with for various reasons. Okay, so the U.S. and I ordered them in terms of their GDP per capita (PPP) from 2018, and we're going to kind of see, well, can we see some patterns? Okay, can we see some patterns here? So first of all, though, back to our living on $1, Guatemala. Okay, PPP is around 8,000 and Gini is 48. 48 is pretty high. So this is out of 100. And so you can think of it as 0.48, right? Or you can think of it as being from 0 to 1. So 0 to 100 or 0 to 1, same idea, okay? They just scaled it up. Colombia and Brazil, 49.7, 53.3. Again, pretty unequal. So quite unequal. And Mexico's GDP per capita is almost 20,000. Remember, I've said that about Mexico's GDP per capita is actually quite high. It's at the very, very, very upper end of what would be considered middle income, which a lot of Americans are surprised about that. But they're very unequal. Okay, inequality again is about 50, and again 50 is considered really high. Okay, 50 is considered really high. So it's about half of the maximum, and the maximum is one person has everything. That's how you interpret that idea. So anyways, it's pretty high. And so this kind of goes back to the same idea that we said, well, on average, countries in Latin America are much more unequal than countries in the rest of the world. And this is pretty universal across most countries in Latin America. Okay, so let's see the next thing. The next thing I wanted to look at is well, South Africa. Okay, South Africa, really unequal. So currently, I believe South Africa and Namibia have the two highest inequalities in the world. Brazil and some other Latin American countries used to be right there with them, really, really close. But actually, inequality has gone down in most Latin American countries. It has gone down somewhat in the last decade or so. Okay, but this high inequality in South Africa is not necessarily universal to all African countries. Okay, because for example, here South Africa, but here is some other countries in Africa, and inequality is, in case of Ethiopia, is not very high, and then the other two is kind of moderately high, right? So inequality is not universal across Africa the way it is in Latin America. In Africa, there's a much bigger diversity of outcomes in terms of inequality. Okay. Then the last thing I want to look at, or a few last things. Asia. So here's Vietnam. Here's China. Actually, China's number has gotten better recently. It was getting worse and worse and worse at some point, and then now it seems to be getting better and better. This may be evidence, and what's happening in Latin America may be evidence that the Kuznets hypothesis has some validity, because actually we're seeing that, yes, in those countries, now that they're getting to the upper end of middle income, in many cases, their inequality is starting to rise. And the last thing I want to look at is, this is just a sample, but the U.S. inequality is unusual. So U.S. is much more unequal than the European countries, for example, than most European countries. And it's also much more unequal than most countries at a similar level of economic development. So, and there's quite a few reasons behind this. There's quite a few reasons behind this inequality. But yeah, U.S. is unusually high. And it's, like I said earlier, it's also much higher than it used to be. And this is quite concerning for a lot of people. But the U.S. income distribution is not polarized. So it's not polarized the way that we defined it earlier, but it is quite unequal. But it's more a case of the top, I would say 30-40% of the population controls a tremendous amount of the income. But it's not the case where it's not necessarily just this 1% issue. It's more like the top 40% of households have a tremendous amount of income compared to everyone else, especially compared to the bottom 40%. So anyways, so these are some Gini numbers. We'll come back and look at a little bit more at these things in a second. One last thing is they can also do a Gini coefficient for the entire world. Okay, so you put all the incomes in the entire world into one Lorentz curve, and then you get a Gini coefficient. And this Gini coefficient is higher than individual countries. The reason it's higher is because there's not only the differences between individuals within the country, but we also see these big international differences. So this is the Gini coefficient you would get if you went back to that global income distribution, and you sort of turn that into a Lorentz curve and then calculate your Gini. But one good piece of news is that this is shrinking. So it used to be about 0.7, and now it's getting close to 0.6. Okay, so it is shrinking. So inequality in the world is also shrinking. So not only is the world not polarized to the extent it was back in the 1970s, for example, but also the income distribution is not as unequal. And so this is, again, evidence that there has been some degree of catch-up going on. I'm not totally sure where we are now. This is from a 2009 paper. My guess, if I had to guess, I would think it has gone down a little bit since then. Because since the financial crisis, the wealthier countries like Europe, US, and Japan, for example, all of them have had relatively slow growth, and there's actually been pretty good growth in much of the developing world. So my guess is the Gini is a little bit lower than this now, although I can't say that for certain because I don't have the data on that.